Hello everyone, this is Robert and this is the controller for my LXmini speaker project. In this video I want to talk about machining the back panel and the underneath side. There's a lot of holes and a lot of connectors, so I want to show you how I did that with my CNC router. So let's get started. As always, feel free to use the chapters to skip around in the video. So this is the controller for a pair of speakers I'm building. It's basically an amplifier, digital signal processor, crossover, all of that into one tidy little package. The enclosure comes from DIY Audio Store, link down below. Kind of comes as this base enclosure. I put in the VU meters in the last video, and now it is time to cut out the back panel and the bottom where everything sits. This is already done through the magic of video editing. I'm doing this in the future, and what you're going to see next is in the past. It's amazing. It's incredible. We live in the future. So we take off the top panel, and you can see just how much stuff is crammed into here. So these panels all come, obviously, unmachined. There's no holes in them. So what we need to do is put all these holes in the back and all the holes in the bottom for mounting. So let's go ahead and start with the back panel. In the previous video, I talked about my process for holding thin metal parts on the CNC router table using the tape, and glue method, but this is a little bit different because these panels already have mounting holes in them. They're obviously not meant to be mounting holes, they're just, screws that attach to the rest of the enclosure, but we can leverage those. So basically what you want to do is use the CNC machine to cut those holes into your spoil board, or here into the MDF. You cut those holes, and then guess what? They're going to be in exactly the same location for the faceplate or the piece that we're cutting. So you can just screw that part down, and if you don't re-reference the machine, you already have your reference set up. So by using the template for the part itself, you can locate the mounting holes. It's arbitrary where the center goes. You can just kind of pick an open space up on the machine, drill the 4 mounting holes, screw it down, and you have everything referenced and located. Pretty simple. Since this is a relatively long and thin piece, I'm worried about the middle kind of coming up a little bit, and I can kill 2 birds with 1 stone. Still kind of dialing in the feeds and speeds for cutting holes. So what I'm going to do is do a test hole in the middle, which actually does correspond to one of the holes that I need, but I'm just going to drill a hole in the middle, and this will give me an additional mounting point and let me test the settings that I have. So now that everything is set up, it is time to start drilling the holes. I'm going to start with the little guys. These are all the screw mounting holes, and these are going to be done with a number 3 spot drill, which is about 1/8 of an inch at the end, or about 3 millimeters. So we're going to go ahead and drill these, and then when those are done, I'm just going to give it a light deburring by hand. So now we're done with the center drill, and now we move on to the 1/4 inch end mill. This is a 2-flute 1/4 inch end mill, and for this I'm going to be machining out the holes for the speak-on connectors, which are large holes that sit at either end, and then the AC input. And the Avid CNC really works well with this type of application. High spindle speed, relatively fast travels, and the parts really don't need to be super rigid. I'm not hogging out a ton of material. This is where it does really, really well. And you can see it leaves a really nice clean finish, and yeah, it's really easy to program, and yeah, very satisfied with the results from this. This was the only operation with the 1/4 inch end mill, so I'm testing the fit before I move on to the 1/8 inch end mill. And as you can see, it's a pretty tight fit, but if you get everything lined up, they do go in there. It is meant to be pretty snug. I want these to be really, really tight in there. I don't want to see a reveal along the outside edge, so this is a perfect fit. And now we can move on to the 1/8 inch end mill. Since the Z offset really isn't all that critical here, I'm just using a 1-2-3 block to set the tool height. It's kind of the quickest and easiest way to do this. Don't have to break out the probe or do anything like that. Ultimately, I'm just machining down through the panel into the spoil board, so the Z height is somewhat arbitrary. I just need to kind of get it mostly right. So you just kind of use a 1-2-3 block to measure or gauge how far away you are from the workpiece, and then just type that number into the DRO. Easy peasy. For the 1/8 inch end mill, there's a couple RCA jacks, I think the optical port, and then the 12-volt trigger. And then also there's a pocket for the USB jack. I'm not actually breaking out the USB jack. It comes off of the end of the DSP and it sticks out a little bit, so I just need to kind of make a recess or pocket to give it clearance, but I'm not going to go all the way through because there's no real need to hook up USB to this ever, and it's kind of a complicated shape that I don't want to mess with, so I'm leaving that off for now. Unfortunately, you can't machine squares or rectangles. Well, you can, but that's for a whole different video. So I need to come in with a 1/16 inch end mill and basically clean up the AC inlet and the optical input, because those are pretty much square. There's a little bit of radius on the AC inlet, but the optical is basically square. So I'm probably gonna even have to file that a little bit, but the 1/16 inch end mill is pretty straightforward. Run it really fast in terms of RPM, and then just come in and clean up those corners as sharp as I can. So that's all we need to do on the router for the back panel, and now I'm just going to bring it over to the drill press and manually countersink all these screw holes. I want everything to be flush, so I'm just going to countersink everything that needs it, and this panel should be pretty much done. Okay, so I got the panel all done, and it looks nice. I got all the countersinks in there, but I did notice one issue that I'm not going to be happy with. So if you look at the XLR jacks, this one fits in just a little snug. Look at that. That is nice. That fits really, really nice. That's what I was going for. Take that out, but the AC inlet doesn't have as much of a lip on it. And it fits in there, you know, okay, but look at that hideous, disgusting lip on there. So it's sitting about 440 thou too low, about 1.2 millimeters. And so it just looks weird, and the inside surface finish of that wasn't that good from the 16th inch end mill. So what I'm going to do is I'm actually going to put this back, pocket this back out so it will actually sit further down in, so then the front will be perfectly flush. So yeah, I know it's a little excessive, but that's what I'm gonna go do. Okay, so that took a little bit longer than I thought. Turns out the model I had for this wasn't actually correct, so I had to redo the model. But there you go. Here's your little cutout on the back. That sits in there, and now look at that. It is perfectly flush on the top. So if we drop in our screws, much, much better. So yeah, I like that. Now to do this entire process on the bottom panel. I'm just kind of lining up the bottom panel where I want the 0 point to be. I'll just 0 the X, 0 the Y, and then I can use this location to drill the mounting holes, and then we can go through this whole process again. Although this process is a little bit more straightforward from the bottom panel because we really only have the screw holes, there's no other features, so I don't need to mill anything. I am literally just using that spot drill to drill the holes. Now, this is probably too late to say this, but if anyone's watching this thinking like, "Ooh, I wish I had a CNC machine," or "Oh, you're only doing this because you have a CNC," well, as you saw, I did do the original prototype of this with a laser cutter. So if you have a laser, you can just use that to mark the hole locations and then just drill those by hand. If you don't have a laser, you can literally just print this out on a piece of paper. You can do 1-to-1. You might have to split it up over a couple pieces of paper, but you can just print out on a piece of paper, save as a DXF or even a PDF, print out 1-to-1, tape it over top of it. You can use that to kind of line up the vent holes. Tape it over top, mark the locations, drill through it like that. Obviously the back panel is going to be a little bit more tricky, but you know, get out some files and file it. It's really not that bad. The CNC is obviously a lot easier. There's a little bit more setup and a little bit more knowledge involved with the cam and everything, but ultimately you could get this exact same job done with hand tools, but I have a CNC, so that's what I'm using. And here we are back at the workbench. It's come full circle. So we've got everything hooked up, not wired up. That's another task for another day. You can see what the back plate looks like, and then obviously the bottom, everything is mounted. I thought I had a video of me mounting everything on the inside, but apparently I did not record that. So Unfortunately, you don't get to see a quick time lapse of me doing this on the inside for like 5 minutes. So anyway, that's what this looks like. The only thing that's left to do really is just to wire this up. It's all programmed, it's all ready to go. Everything is set. You saw the touch panel in the previous video. So yeah, I just have to wire this up. The speakers are almost done. I have everything kind of machined for the feet. I need to do a couple more 3D prints, but those are basically down to just kind of final assembly. So hopefully I'll get those videos done here soon. I just have some other things coming up, and the house isn't even ready for these yet, so no big rush there. But in the future, I will have the full finished final video on this. I'll have the finished video on the speakers, and then we can start doing some listening impressions and maybe do some measurements. So as always, thanks for watching. Check me out on all the new videos I'll be posting, and see you in the next one. Bye.